Welcome. Hope you all can hear me. Can you guys confirm once? Am I audible?
Yes, sir, you are audible, sir.
Okay, great. Thanks for confirming. So let us start this session, guys. So if you guys remember, in our yesterday's session, we have completed the very first demo session, right? First demo completed yesterday. Those people who have not attended the first demo, please connect with an admin. They will share you the recording. Please watch the recording. Okay, so today we are having the second demo. Okay, today we are having the second demo. Yesterday we have completed the first demo, guys. Those who have not attended the first demo, please connect with the admin, try to get the recording, please watch it. Okay, so that's what please try to do that. And for the second demo today, what we are going to see, we are going to start with an actual topic today, that is what is our cloud overview. So let me gonna show you what we are going to start. The actual topic that we are going to start, guys, that is, please mute yourself. If you guys have any questions at any point of time, please raise your hand. Okay, so let's not disturb any other people. Try to raise the hand if you guys have any questions. I'll give you the time. Okay, yeah. Now, what we are going to see, let me gonna talk about it. So that we are going to start with the cloud basics. The very first topic, that is cloud overview. We are going to understand why we need the cloud platform and what is the difference between the on-premises versus cloud platform. Right. So this is an actual topic that we are going to see. And we will also see what is Google Cloud Platform introduction and these basics also. Maybe in tomorrow's session, we will see the GCP interfaces, console, Cloud Shell, SDK, and afterwards, subsequent classes, we are going to see all of these things. Today, I am going to more focused on this particular topic, which is a small topic only. Okay, we are going to see this one. Right. Why we need the cloud platform? Tell me, guys, why we need the cloud platform? Anyone? Okay. Okay. Any other answers? Security. Okay. Cost of cost
Capacity.
effective. Very good answer. Okay. Scalability. Yes. Correct. Okay. Let me gonna show you. Okay. Let us try to take an example, and we will try to understand how an end-to-end application deployment looks in the companies. Okay. Usually, how people were working in the on-premises working model and how cloud came into the picture, we will try to understand today with an example, so that you will understand end-to-end flow. How many people involved, how many teams involved in an entire one product deployment, how many teams are involved. Let us try to understand with an example. Okay, so to do that, let us try to consider there is a company, and that particular company wanted to create a new application. Consider that you are working in a company and your company wanted to roll out a new application. Your company wanted to roll out a new application. For that one, business comes up with a requirement for the application. You will be having a business. The business comes up with the requirements for the application. Whatever the application that you wanted to create it, that requirements, the business will come up with that. And then business analyst will be there. He will gather all the needs from the business, and he analyzes that information and converts that into a set of high level technical requirements, and then passes that information to the solution architect. Right? Business comes up with the requirements. And business analyst will gather all the needs from the business. All the needs, nothing but why the application is needed, for whom it is needed, what is the requirement, all of those details. And he analyzes that information and passes that information to the solution architect. Now, solution architect is the one who designs the entire architecture to be followed for the deployment of the application. Right? These people wanted to create a new application. This guy, uh, you know, gather all the information or the needs or the whatever the details that are required for the application. He converts that into a technical information and he passes that information to the solution architect. Now the solution architect is the one who designs the architecture to be followed for the deployment of this application. The entire things that are required to follow for deployment of the application. For creating an entire new application, whatever the steps that are required, he will be creating an architecture diagram. In this thing, he will mention what is the programming language that we are going to use, how many developers are working, what programming language, what is the process, how the technicality, all the technical things. Similarly, he will also mention about the infrastructure details, such as how many infrastructures are required, such as the specification type, how many number of servers are required, the front-end web server, back-end web server, back-end databases, load balancers, everything. Right? If an application wanted to deploy, sir, if I wanted to create an application, two things required. If I wanted to create an application, two things required. Tell me, guys, what are two things? One is developer, right? The developer. The if I wanted to create an application, the developer needs to develop a code, right? So developer needs to develop a code. The second thing is infrastructure. Whatever the code that is developed, it has to be deployed on top of the infrastructure. Infrastructure could be the software, databases, storage, networking, everything. It will include everything. Servers, databases, load balancers, and everything. So while the solution architect is designing the architecture to be followed for the deployment of the application, he will mention all of these details. He will mention all of these details in the architecture diagram. You can think that this is an architecture diagram where everything is mentioned for the deployment of the application. So the entire things that are required for the deployment of the application is properly provided in the architecture design. In terms of the programming languages, in terms of the developers, in terms of the application development team, in terms of the infrastructure, in terms of the servers, backend databases, load balancers, and everything. Now tell me, guys, if I am following a traditional model or if I am following a on-premises working model, the whatever the infrastructure that is mentioned in the architecture diagram has to be maintained by whom? Right. So in this one, he mentioned some amount of infrastructure. Okay, some amount of a code details. So this infrastructure should be created by whom when you are following a traditional model? Tell me. Correct. So when you are working in a traditional model, when you are working in an on-premises working model, the entire infrastructure that is required for your application has to be maintained by your company's data center only. Your company has to maintain their data center because you do not have any other solution, alternative way at that point of time. Just go 10 years before, 15 years before. Your company has to maintain your data center. Your company, this is your company. Your company has to maintain this data center, right? So in the data center, you will be having two types of resources will be there. One is physical resources. One more is virtual resources. Physical resources and virtual resources. So a data center is a collection of physical resources and virtual resources, and the resources are properly organized in a rack and stack mechanism. You will be able to see here. This is called as a rack and stack. All the hardware, all the infrastructure, all the raw material, servers, everything is properly organized into rack and stack. You are able to see here. This is what we call as a rack and stack. This particular, so you will be able to see this is how the data center will be established. Inside the data center, you will be having the rack and stack like this. Every day, the security person has to be maintaining the data center. So 24 by 7 electricity has to be supplied. 24 by 7 water supply. 24 by 7 security should be there. 24 by 7 maintenance should be there. Okay. So maintaining the data center is not that easy. Maintaining the data center requires a lot of money, lot of effort, lot of time also we have to invest. So when you do not have a when you do not have a cloud platforms, your company has to invest a lot of time maintaining the data center, invest a lot of money maintaining the data center, lot of effort also to maintain the data center. And now tell me guys, now tell me one thing. The solution architect mentioned some amount of infrastructure required for the application deployment, right? So if some of the infrastructure may be readily available already in the data center, what if some amount of infrastructure, some of the hardware is not available in the data center? What we have to do? Right, assume that some 5 infrastructure details are required, but out of 5 only 3 available. For example, 2 servers are not available, or 2 databases are not available in the data center. What we have to do at this point of time? What company will do at this point of time? So we cannot be able to deploy it without the entire infrastructure. Some amount of infrastructure is not available in the data center at this point of time. If the additional hardware is required, it has to be ordered via procurement team, right? They have to order it via procurement team, and this team will put in a request to the vendors team. This team, the procurement team, will place a request to the vendors team. Now the vendors team will visit multiple shops. They will purchase the hardware and deliver it to the data center. So what the vendors team will do? They will visit a multiple shops. They will purchase the hardware. They will deliver it to the data center. This will take days, weeks. Sometime it will also take months also for the entire hardware to be purchased and deliver it to the data center. Right? So that is what. Once it is received at the data center, we cannot directly use. Can we use it directly? No. Once it is received at the data center, that's where the field engineers comes into the picture. They will again arrange this entire hardware into the rack and stack, which I have shown you, right? They have to arrange it like rack and stack again. So who will be doing that? A field engineer will be there in the data center. He has to, or they have to arrange the entire hardware which was delivered. Whatever the hardware is that is delivered at a data center, they have to, you know, arrange it like rack and stack like this. Okay. So now you see the field engineers will take care of the rack and stack equipment. Then the system admins will take care of the initial configuration of the system. Okay. So once the entire hardware is delivered at the data center, field engineers will take care of the rack and stack mechanism, and the system admins will take care of the initial configuration of the system. Network admins will configure the networks also so that every system is available over the network. Then storage admins will assign the storage. Backup admins will configure the backups. Once everything is ready as per the standard, once the entire infrastructure is ready as per the standard, it will be handed over to the application team. It will be handed over to the application team. Now the application team will deploy the code on top of this infrastructure, will deploy the code on top of this infrastructure. Then your application is running here. So this is what is the entire process to be followed by the companies who are following the traditional working model. When you are working in a traditional working model, each and every step is important here. Everyone must be working closely to complete this entire thing, right? You see why I am telling you this one. You have to understand the challenges that they were facing. Then only you will appreciate the technology of the cloud. Okay, see, when you do not have a cloud platform, these many teams, right? If you wanted to create an application, the business comes up with a requirement for an application. The business analyst will gather all the needs from the business, and he converts that into a set of high level technical requirements and passes that information to the solution architect. Now, what is a solution architect is doing? The solution architect will design the architecture to be followed for the deployment of the application. He will design the architecture to be followed for the deployment of the application. This entire architecture will involve a lot of things, including the infrastructure. When you are following a traditional working model, you have to deploy everything in your organization data center only. Your organization has to maintain the data center. You have to deploy everything in the organization data center only. Whenever the additional infrastructure is required, they have to order it via procurement team. Now the procurement team will place in a request to the vendors team. Vendors team will deliver everything, purchase the machines or purchase the hardware and deliver it to the data center. Once it is delivered at a data center, field engineers will come into the picture, system admins, network admins, storage admins, backup admins. Finally, the application team, whatever the code that they have developed, application team, nothing but developers. Whatever the code that they have developed as per the standard, they are going to deploy on top of this infrastructure so that your application is running smoothly here. Your application is running smoothly. So this is what is a on-premises working culture, traditional model, right? Traditional model or an on-premises working model. Now tell me guys, what are the disadvantages you see here? What are the challenges that you see here when following the this particular thing? What are the challenges that you guys see? Okay, one say time consuming. Okay, any other answers? Main lot of maintenance, correct? Any other things? Okay, could be. Okay, security issue. Cost, very good answer. Cost is very high. Yes.
Low availability when there is a failure.
Okay, correct. When there is a failure, availability is lesser. Correct. Okay. So now let us try to see the disadvantages. So now that you understand the traditional working model, how it works, which is very important for everyone too, because whoever is working in the cloud, they must understand what were the challenges that were imposed by the traditional working model. Now you will be able to see one of the first thing is slow deployment model. Already one of the person was mentioning, sir, that it is time consuming. Nothing but the turnover time varies from the weeks to the months for the everything to be ready for the application deployment. You already seen if the additional hardware is required, we are taking a lot of time to purchase it and deploy it to the data center. And similarly, multiple teams are working on behind the scene. Rack and stack has to be done, networking, all of these things, it will take a lot of time. So that's the reason for the entire deployment, it will take a lot of time. So that's the reason we call it as a slow deployment model. Does it make sense? Right. It's a slow deployment model because it is a time consuming model. So everything is taking a lot of time here. Okay. The second thing, which is expensive. We already know that the overall cost to maintain the model and deploy the model is very high. Because the moment you are trying to maintain the data center 24 by 7 electricity, 24 by 7 cooling supply, 24 by 7 security, maintenance, field engineers, everything is again many teams behind the scene. So procurement team, vendors team, field engineers. So because of these many people, because of these many things, the overall cost to maintain the model as well as deploy the model is generally high. So that's the reason I'm calling it as an expensive model. I hope this is also making sense. Tell me, guys, is scaling up and down is achieved quickly or not? Scaling up, assume that your application is doing good, you have to scale up, or your application is not doing good, you have to scale down. So, does it achieved quickly or not? The answer is no. Right, so scaling up and down as per the demand, as per the infrastructure, as per the demand cannot be achieved quickly at all. Because if you wanted to do it again, you everything again you have to start from here. If you wanted to scale up again, you have to start from here. Everything you have to follow. Right, so scaling up and down is also not easy. And one more thing, limited automation. While some aspects of the infrastructure can be automated, but several steps, you can look at here infrastructure details such as field engineers, whatever they are doing, rack and stack, cabling, or system admins, initial configurations. These are all steps are manual and slow, right? So most of the steps are manual here, and the manual steps are slow. So the automation is limited here. The moment you are working in the on-premises working model, most of the things are manual only. The manual things are very slow. So that's the reason we call it as a limited automation. We call it as a limited automation because most of the steps cannot be automated at all. They are manual and they are slow. And one more thing, with the so many teams working behind the scene and so many different tasks, the chances of the human error is very high. Right, so many teams working behind the scene and so many different tasks, the chances of the human error are high, which may result in the inconsistency in the environment, which results into the inconsistency in the environment, guys. Can anyone guess it? The major disadvantage, I did not tell you the major disadvantage. Can anyone guess it? The major disadvantage. Nope. No. 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 Any other answers? Scalability we talk already. No. Okay, let me gonna tell you. Wasted resources. What does that mean? Can anyone guess what is mean by wasted resources? Correct. Underutilization of the compute resources is nothing but wasted resources. See, you think that you are going to purchase a lot of infrastructure which is required for your application, but you may not be using it 100%, which is a major disadvantage on all of these things. That is nothing but wasting the resources. The major disadvantage is underutilization of the compute resources. Okay, so you have a, so the traditional model, the moment you try to use the traditional model, it is a slow deployment model, it is expensive, limited automation, human error, inconsistency in the environment, and wasted resources. Due to these many disadvantages over the past decades, companies were looking for an alternative solution. Companies were looking for an alternative solution. So that's where the cloud platforms come into the picture. That's where the cloud platforms came into the picture, guys. So the cloud providers providing you the cloud platforms now. The moment you are working in the cloud platform, so you don't have to worry about these many teams. This entire thing is not required for you. Right. So when you're working in the cloud platform, you don't need the field, you don't have a data center at all. You don't have to maintain the data center when you're working in the cloud platform. You don't need to have a field engineer, storage admins, backup admins, system admins, network admins. These many people does not require at all. Right. So the moment you are working in the cloud platform, you don't need these many things. And instead, you just need one of the infrastructure engineer or DevOps engineer, we call it as, who is ready to create the resources in the cloud platforms. That's it. Right? So if you want some machine, you can create in the machine. If you want some database, you can create in the cloud platform. If you want some kind of a cluster, you can able to create in the cloud platform. So you don't need to set up your own data center. You don't need to maintain your data center. You don't need to worry about your data center maintenance at all. So what happens here is that most of the resources are provided by the Google cloud platforms itself. So what cloud providers will say is that cloud providers will provide you the cloud computing services to you and a pay-as-you-go model. Cloud computing services are provided by the cloud providers and a pay-as-you-go model. So whenever the required resources are required for you, you just go to the cloud platforms and you create them. You start creating them. Whatever the resources you are utilizing, you only pay for that. Whatever the resources that you are using, you only pay for that. So that is what is a cloud platforms and cloud providers, guys. So the major cloud providers like AWS, Azure, as well as Google cloud platform. So these are the three leading cloud providers. We are going to focus on the Google cloud platform from now on. Okay, so that is what. Okay, so you can see here, guys. So when you are working in the cloud platforms, you do not have any of these teams, right? So tell me, guys, when you are working in the cloud platform, is the deployment is comparatively slow or faster? Is the deployment is slower or faster? Yes,
Faster.
it will be faster compared to the on-premises working model. When you're working in the cloud platforms, the deployment model is very faster because you don't have to depend on the data center. You don't have to depend on these many teams. The moment your application code is developed, you can request an infrastructure engineer or a DevOps engineer to create a resource in the cloud platform. They just spin up it in a one day, hardly one day or few hours only, so that you can able to deploy your code on top of it. So the deployment model is very faster. And then when you're working in the cloud platform, you only pay for the whatever the resources that you are utilizing. You don't have to pay for anything. So you only pay for whatever the resources that you are utilizing for your application. So that's the reason comparatively it is cheaper. Right? When you're working in the cloud, comparatively it is not expensive. And one more thing, the automation is very high in the cloud platforms because everything in the cloud platforms works via API only. Everything in the cloud platforms works via API, application programming interfaces. When everything is connected via API, the automation is very high. You can able to automate most of the things. Most of the things you can able to automate because every service is connected via API only. So the automation is very high. And You do not have these many teams now. You do not have this team, no, these many teams are not there. Right? When you do not have these many teams, the human error will be less. The inconsistency in the environment will also be lesser. Right? So the human error is lesser and inconsistency in the environment will also less. Now, wasted resources. So you only use whatever the resources that are required for you, because in the cloud platforms there is a auto scaling feature is there. So auto scaling, so if your requirement is more, that means if you need more amount of infrastructure, then the infrastructure will be auto scalable, scaling up. If the demand is lesser, the scaling down will be there. So most of the resources in the Google cloud platform or any other cloud platform, the scaling up and down is automatic, so that you, the concept of wasted resources will be still there, but comparatively it will be lesser. Less wastage will be there in the cloud platforms. So this is how, or this is the reason that most of the companies started looking towards the cloud platforms, because when they were working in the traditional working model, they were facing a lot of challenges. But the moment they started working on the cloud platforms, they started seeing a lot of improvement when it comes to the cost, when it comes to the effort, when it comes to the scalability, when it comes to the automation, as well as human error and deployment faster. So all of these things, they started looking at the cloud platforms. Okay, so this is what is the reason that why we need the cloud platform. And this is a reason that most of the companies are started looking towards a cloud platform. Already most of the companies moved to the cloud, and there are still companies moving to the cloud already. Now that you understand why we need the cloud, you also understand one more important step, that is, what is the difference between the traditional as well as cloud? What are the challenges that the traditional systems are facing, and how the cloud is fixing those problems? You also understand the entire flow of application deployment in the companies, how these many people are interlinked. Right? So you understand all of these things. In a simple words, just wanted to say one thing: the difference between the on-premises and cloud, you can see here in a simple words. When you are working in an on-premises, an organization, your organization has to maintain your infrastructure to run their application. You have to, or your company has to maintain their own infrastructure to run their code. That is what we call it as a on-premises working culture or a traditional working model. So if you wanted to create an application, you maintain everything on your own. That's called as a traditional working model. Sir, what is meant by infrastructure? Every time you are saying that, sir, infrastructure. An infrastructure could be a server or a hardware or a software or a networking or a storage or anything. Okay, so this is what. And what about the cloud computing model? In a cloud computing model, the infrastructure is delivered by the cloud platform. The infrastructure is delivered by the cloud platform. What do we do, sir? We develop the code, we deploy the code on top of it so that the application is running. Right? So in the cloud platform, we more focus on innovation rather than infrastructure. That means we more focus on the development rather than the infrastructure building. So that's what the cloud platforms will do. So the motto of the cloud platforms is that we provide you the resources that are required for your application. You focus on the innovation, we take care of your infrastructure. That's the main motto for the any of the cloud platforms. And they again work as a pay-as-you-go model. For this code application, whatever the amount of resources that you are using, you only pay for the cost for it. You don't pay more than that. So this is what we call it as a cloud computing model. In a cloud computing model, infrastructure is provided by the cloud platforms, and your company has to maintain the code, deploy the code, and develop the code. Okay, so this is what is nothing but cloud computing model. Okay, so that's what. Now let me gonna give a small break. If anyone have any questions, you can ask me, guys. Please raise your hand if anyone have any questions and a high level questions if you guys have. I hope most of the people are able to understand why we need the cloud platform and what is the difference between the on-premises versus cloud platform. If anyone have any questions on a high level, please raise your hand. Please raise your hand. Do not talk directly, please. Yes, Narendra, you have any question?
Yeah, today is my first session.
Okay.
So, could you please give for 5 minutes in the last
Yes, I'll do that.
end of the
Yes.
session? So, what are the topics we will
Sure.
cover?
Sure. I will do that.
Those things.
I'll
That
do
would
that.
be great.
Sure, I will do that, Narendra. Yes. Yes, Akash, you were asking something. Sorry. Everything will be provided to you. Yes, material, everything will be provided to you. While once you guys are enrolled for the course, you will be having an access to all the material. Yes. Okay. And yes, Shiva, you have any question, please? Yes. Correct. Correct. So the infrastructure, storage, memory, rack, and everything is handled. Okay, everything is handled or managed by the cloud providers only when you're working in the cloud platform. When you're working in the cloud platform, when I say infrastructure, including everything. Okay, even they do the maintenance also sometimes. They do the maintenance for you. They do the upgrades for you. Okay, so that's how that there's a very good advantage for the. So that's the reason nowadays the work for the admins is reduced. Even they are actually moving to the other areas. Okay, so that this is a reason actually. Yeah. Okay. Correct. Correct. See, that's what is happening. That's what I'm telling you. If we are not upgrading ourselves, right? If we are not upgrading to the cloud, big problem for those people who are working in the on-premises. Already, most of the companies laid off those people who are working in a traditional systems. Okay, we should be upgrading ourselves. Otherwise, in a big trouble. Yeah. There's a data centers also. We will be talking that. We will be talking that. Okay. Sure. Yeah. Yes, Prasad, you have any question? Huh. So yes. So when you wanted to migrate it, so this is a very good question, sir. The question is, so if you guys wanted to migrate from your on-premises to the cloud, yes, there are plenty of the things. See, if Google Cloud Platform is like a person, if they wanted to attract more people to use the cloud platforms, they should providing you the ease when it is for the migration, right? So that's the same thing what the Google Cloud also will do. So if you assume that you have a Hadoop cluster which you wanted to move it to the Google Cloud platform, very simple to migrate it because it's just a cluster. The same configuration will be available, the same setup is also available, same resources also available. The only thing is interface changes, and now the cluster is maintained by other people. Okay, so that is there. So such kind of things we will be seeing in our upcoming sessions. Okay. Uh, that's what I'm telling you. So that's what, whether it is a cluster, whether it is a code, whether it is a pipeline, whether it is a data, right? All of these things you have to migrate it. Huh. Yes. Okay. Yes, Amit, you have any question? Amit.
Sir, I just wanted to know that as you have said about the migration. So, migration is it a continuous process or it's a one-time
One time
process?
process, right, sir? One time process. See, I have a 1 GB of the data in my on premises. But from now on, my company wanted to operate it from the Google Cloud platform. You just move it to the 1 GB to the Google Cloud platform. Then you try to you remove your entire on-premises. You decommission your entire on-premises working culture. You start working in the cloud itself only. So that's a one-time process. Okay, migration is a one-time process. Once it is migrated, you will be working in the GCP only. Okay. Yes. And yes, Manish, you have any question? Manish,
Yeah.
yes, please.
A question which I have is regarding
Uh-huh.
cloud utilization, right? For small size companies, it's okay to go ahead with cloud,
Uh-huh.
but the companies that have a larger business, they are avoiding cloud these days. So how to kind of like take care of these things in the software development world, right?
So it's
For
yeah.
them, the long run cost is higher on the cloud. So how do we come around and take things forward?
It's like this one. See, if I have a cloud, so some of the companies may have a lot of things on their on premises. So it's like this that they don't have to move everything to the cloud. Okay, some of the things, for example, nowadays the ML or maybe the GNA work or some amount of a things which they wanted to do it, get a benefit of those. So such workloads they can able to move it to the cloud. Not everything to be moved to the cloud. Okay, not everything they wanted to see. Everything for a small companies they can move it to the cloud, they can operate it easily. But the thing is, for a larger companies, for like a enterprise companies, it's their wish to move it to everything to the cloud. If they don't want it to move everything to the cloud, but some aspect where the technology needs, some aspect where they wanted to more focus more on a innovation rather than an infrastructure building, right? So they can focus more on the such a kind of a things to the cloud, so that they get a benefit of not only the time but also the cost as well as the effort, right? Such kind of a things, right? For example, I would like to create a Gen AI application or maybe the ML model, right? So if you wanted to do such a kind of a setup in the again in the on premises, you have to build it everything from the scratch. Instead you go to the cloud, you make use of the cloud resources. Okay, such kind of a practice that the most of the companies started doing it already. Step by step they started moving everything to the cloud. Yes.
Correct. So the question here is the same. If we are going as expert of the cloud, right?
Mhm.
Uh, the company would be looking forward to us to suggest them.
Correct, that's what.
Correct. So what should we take as our base when we are suggesting such things, right?
No,
Like
that
AI,
requires a full
ML,
knowledge. Yes, that
yeah,
requires a
AI,
full knowledge
ML,
of.
correct. AI, ML is very new thing. What the big companies are doing now, even for their basic servers also to put on the cloud, they are like saying the cost is not that effective. In the long run, it's going to be more costlier as compared to the on-premise servers or the infrastructure.
See,
So
that's what I'm saying. Wherever they see, it's something that if they see, if they are looking for a benefit, and if they see a benefit, or if they see a cost effective, or if they see a effort reduced, such things they can able to move to the cloud. And you try to do a POC for that. You try to do a POC for that and try to check it out. The amount of a cost that is you are spending on the on premises, as well as the amount of a cost you will be spending when you move it to the cloud. It's not one way, it's not just a one single time I just say this thing is a good and this is not a good thing. It is not, it doesn't work like that. So we have to work, we have to look closely, we have to work with them closely. We have to try to do a POC for them, proof of concept, saying that hey, is this really worth of moving to the cloud? And if it is, then what is the benefit in terms of the cost, in terms of the effort, in terms of the time consuming, right? You try to design the entire thing POC, you get some kind of a metrics, you suggest them, hey, this is what you are going to do, this is the benefit that you are getting it. And some cases you get a lot of benefit, some cases you get a nominal benefit, in some cases you don't get any benefit. So based on that you suggest them, hey, this is what is, this is the best thing for you to move it to the cloud, right? So, that's how we have to do. It's not that one single way, hey, I say everything is there in the cloud, I wanted to move it to the cloud. But I am telling you, most of the companies started utilizing the cloud. They started seeing the benefit in the cloud, even in the long runs also. But the only thing is that we have to look at that particular use case. We have to work closely with them. We have to help them or suggest them with these kind of a scenarios and metrics.
Right. Thanks.
Yes. Okay. So this is all about them. Yes, Amit, you have any question?
Yes, sir. Sir, I would just request if we can also hear the question, so it will be
It will be. You will
absolutely
be
nice.
from Monday onwards. You will be here from Monday onwards. Yes.
Okay,
Yeah,
okay.
yeah, yeah. Okay. So now that, sir, we have seen a very good concept, that is why we need the cloud platform. Because if you do not understand that thing, when you are working in the cloud platform, it doesn't make any sense. Why we are now working in the cloud? You say, hey, cloud is good. No, it is not making sense. Now you will understand, hey, because of these many challenges over the on-premises working culture over the past decades, that is the reason most of the companies started moving to the cloud. Still some of the companies started moving the cloud, right? Now you will understand that concept. And now we see what is Google Cloud Platform also, right? So we have seen yesterday also. Let me gonna tell you one more time. So Google Cloud Platform is a suite of cloud computing services provided by the Google. It offers a range of products and solutions to help the organizations to build the application, deploy the application, and scale the applications and services in the cloud. Which I have told you, Google Cloud Platform is one of the leading cloud provider, which provides you the cloud computing services, a range of products and services it offers you. These services are very useful for the organizations to build the application, deploy the application, and scale the applications and services in the cloud. So this is a definition. Google Cloud Platform is a leading cloud provider which provides you the range of products and services for the organizations to build the application, deploy the application, and scale the applications and services in the cloud. And these services are highly reliable, secure, scalable infrastructure that enables businesses to leverage the power of Google's extensive global network and data center. Google has a data centers over the world, and these data centers are situated in different areas, different countries, and different locations. And in India also we have two data centers. I have told you yesterday, in Mumbai one, and data center in Delhi also. Okay. Yes. And what are the services that it is offering? What is the tech stack? What is the entire compute categories? Identity, IAM services, management tools, right? So you can see compute, IAM, management tools, networking services, big data engineer, storage and database engineer, machine learning engineer. Whoever you are, if you wanted to work in the cloud, you have a separate service available here, right? Most of the services offered by the Google Cloud Platform, so that if one wanted to store the data, they can store it. If one wanted to process the data, they can process it. If one wanted to build an application, they can do that. If you wanted to register an application, they can do that. If one wanted to doing the logging and monitoring, they can do that. And manage IAM access management, if they wanted to do it, networking components, machine learning models. So everything is here. Everything is here. So that's what the GCP is offering. Your tech services, all of these, this GCP suite is here, guys. And the next thing that we are going to see tomorrow, that is how to interact with the GCP, which we are going to see tomorrow. Now, I just wanted to pause it here. Now that we wanted to become a GCP data engineer. So now we already know we wanted to become a GCP data engineer, or whoever you are. This concept is common for everyone. If you wanted to become a GCP data engineer or a DevOps engineer or a cloud engineer, whoever you are, if you wanted to interact with the Google Cloud Platform, if you wanted to interact with the Google Cloud Platform, you need to know the interface methods. There are three interface methods are there. One is console. To interact with the GCP, there are three interface methods are there. One is console, cloud shell, cloud SDK. Okay. So if one wanted to interact with the GCP services, Why do we have to interact with the GCP services as a data engineer? Can anyone tell me? Sir, why we have to interact with the GCP services as a data engineer? Please tell me, guys. Please tell me if anyone, if I want, why do we, sir, we are a data engineers, why we have to interact with the GCP services? Okay. What is GCP data engineer do, sir? What is data engineer do? Right. So a data engineer may wanted to store the data. They wanted to process the data. They wanted to transform the data. They wanted to analyze the data. They wanted to visualize the data, logging and monitoring, governance. So if you wanted to do all of these things, where do we do all of these things, sir? Where do we store the data? Where do we process the data?
In cloud.
In this one only. So why we have to interact with the Google Cloud Platform? Because we wanted to store the data. My requirement in the project is to store the data. My requirement in the project is to, they are asking me to process the data, clean the data, transform the data, analyze the data. To do that, you have to interact with the GCP. To interact with the GCP, there are three methods are there, which we are going to see tomorrow: console, Cloud Shell, Cloud SDK. We will see that tomorrow, guys. Let me pause it here. Okay, let me pause it here. And some people may be new today. So for those people, I'm going to just tell you the course content, what we are going to cover on a high level in next 2 minutes. So this is for those people who are new, this is what we are going to cover, guys. The timings are the same timings, that is 7:30 to 8:30 every day, IST 7:30 to 8:30. So this is what is this one. So this is what is a course curriculum, guys, on a high level, on a high level. Okay. You can look at here. We are covering the cloud basics. So this is what is the topic that we have seen today. So do not ask me, sir, these demo sessions, regular sessions will start from where? We already started the regular sessions. Today, one of the session is completed. Cloud overview and GCP introduction. Tomorrow, this topic, interfaces, locations. I am an admin. We will see programming, Linux, Python, PySpark, Apache Beam. Data engineering services, GCS, Cloud SQL, Dataproc, BigQuery, Dataflow, Data Fusion, Airflow, PubSub, Cloud Functions, Databricks. Terraform and Bigtable also covered, but these are the, complementary topics. And projects and case studies. You see, 2 BigQuery case studies, 2 case studies and 1 end-to-end batch pipeline, 2 case studies and 1 end-to-end streaming pipeline, 4 end-to-end DAGs, 2 case studies and 1 end-to-end workflow. So all of these things which we are going to see. Okay, so these are all the things which we are going to see, guys. Now, if anyone have any questions on any of the things, they can raise their hand and I'll ask them to, we will see one by one. Okay, we will go with one by one. If anyone have any questions, you can raise your hand. For those people, if they are good, they can, we can wind up the session, guys, today, because tomorrow we are having third demo, sir. Demo 3 tomorrow at the same time. We have a free demo tomorrow also at the same time tomorrow. Please do not forget to attend. Tomorrow also we have a demo 3 at the same time, guys. The time is same, 7:30 to 8:30. Tomorrow we have a third demo session. Okay. So today we are having the second demo. Yesterday we had first demo. Tomorrow we are having the third demo, and at the same time. Okay. Yeah. Yes. If anyone have any questions, they can please raise their hand. Oh, 1 minute, please. 1 minute, please. I'll go one by one. Yes. Yes, Purna, right? Yes, Purna. Yeah. Mhm. Cloud functions are covered, but Cloud Run and Cloud Functions nowadays both are same. But APG is not covered here. No. No. Well, I mean, we are using the APIs to extract the data from one of the source. There's a API concept will be there, but we are not creating any gateways, but we are extracting the data from one of the gateway. So that's what it is. That's common. That's such kind of things we will be seeing. Okay, so for example, if you have a API, sir, the thing is that if you have a API, whether it is any kind of a thing, if you wanted to extract the data from such kind of a API, we will be doing that. So there's a one of the pipeline, end-to-end pipeline is also there. So where I am using API, for example, for me it is Buzz API, which is a free API. Using the Python, I'm extracting and storing it in the cloud storage. So such kind of a things we will be seeing. Okay. Yeah. And that we will be covering in the session. Okay. Yeah. Okay. So API and Apache is not covered here. Okay. Apache is not covered. Not covered. Not very much important for data engineers. Okay. Cloud functions is covered anyway. Cloud functions, one of the use cases there. The cloud functions, one of the use cases, very interesting use case. Actually, there's a assignment also for cloud functions. So this is a use case. The moment there's as soon as there is a file inside the GCS bucket, you are using the cloud functions to move to the data or to the BigQuery or to anywhere, right? So such kind of things. Cloud functions is more of a event-based solution. Yeah, it is covered again. Yeah. Okay. That we are not covering because that is nothing but API creation. You have to create a gateway for that. That we are not covering. Yeah. 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 Okay. Yes, Amir Sheikh. You have any question? Okay. No, yeah. Okay. I did not tell you this one. So, guys, I just wanted to tell you one thing. Whoever you are, okay. So, whether you are having 1 year of experience, okay, maybe I can write it here only. I'm gonna write it here. Look at here. This is very interesting thing. So, some people may be having 1 year of experience, right? Some people will be having 2 years of experience. Some people will be having 3 years of experience. Some people will be having 5 years of experience. Some people will be having 7 years of experience, 9 years of experience, 11 years of experience, or 11 plus. Okay, I'll just say 11 plus. 11, 13, 15, 17, right? So what they have to do? So you may be working in 1 year means 1 year experience means you are already working in some area. But what you have to do, you are attending my course now. You are attending my course. That is GCP data engineering. Once the course is completed, you have to prepare your resume. You have to prepare your resume saying that last 1 year I have worked on the GCP data engineering. Last 1 year I have worked on the GCP data engineering. Whatever the projects that I have mentioned, right? So those projects you have to put it in your resume. Go for the interview. Go for the interview and crack the interview. So this is what you have to do. Okay. So if you have a 1 year of experience, put all the 1 year in the resume. Okay. Put all the 1 year in the GCP data engineering. I would say 1 year in the GCP data engineering. Put the entire year. And similarly, assume that you are having 2 years of experience. Okay. 2 years. You can put all 2 years or you can put 1 year also in the GCP. Rest 1 year, what I have to do, sir? Sir, for example, I have 2 years of experience. I'm putting in the resume 1 year only for a GCP data engineer. For a GCP data engineer, I'm putting only 1 year. What about the rest of 1 year experience, guys? What do we do? Whatever the current experience you have it, you put the same thing, right? Whatever the current experience you have it, you put the same thing. So that's what you do. So I'm gonna say this is GCP instead of GCP data engineering. GCP, I will say. Okay. So yeah. So when you are going preparing your resume for 2 years, you put GCP 1 year. Okay, for 1 year for the GCP data engineer, and 1 year is your current experience. Whatever the current experience you have it, you put that. Whatever the current experience you have it, you put it. The same thing. 1 year. I'll just properly mention it here so that there won't be any confusion. So you can take a snap of it, guys, later. 1 year, the entire 1 year on the GCP only, GCP data engineering only. Yes. Okay, so this is how. Now the same thing for the 3 years. Sir, I have a 3 years of experience. How can I manage my experience? 1.5 years on the GCP. 1.5 years, whatever you are doing it, current experience, you put it. How do I manage? So I was working in some area, but I have got a chance to work on the GCP. So I have upskilled myself to the GCP. And you can say that, you can go and say that, hey, I worked in the last 1.5 years onwards. I've been working in the Google Cloud platform. These many projects I have worked on it. And I had worked on this area, I have created this many pipelines, and all of those things you can explain it. The same thing goes for the 5 years also. 5 years, you put 2 years of experience in the GCP, and you can go for 3 years your current experience. Okay, so 5 years of experience, last 2 years they are happy to recruit you if you have a 2 years of experience in the GCP. So if you have a 5 years, if you're putting 5 years, or if you wanted to go for 2.5 to 2.5, it is your choice. Okay, it is your choice, but minimum you put 2 here. Minimum you put 2 here so that it makes sense. Okay, minimum you put 2. So that's how you manage it. The same thing here also. Sir, 7 years, put 2.5 instead. 2.5 here. 2.5 years of experience here, and then rest of the 3.5 or 4.5 current experience. The same thing goes for 9 years. 9 years, put 3 years of experience here. Last 3 years on the GCP, rest of the 6 years on the current experience. They will not ask you what you're doing it. See, if the requirement is about the GCP data engineer, they're more focused towards your GCP career rather than your old career. They ask you one question: what were you doing earlier? You say, I was working in this area, I got a chance to work on this GCP. That's it. No questions before that. Okay, so such that. And you have a 11 years of experience, you put maximum 3.5 years on the GCP, and the rest of the experience, whatever you have it, you can put it. Rest, whatever the things that you have it, you put it here. Okay, so that's all. Maximum you go for 3.5 years with this course. Maximum 3.5 years you can go. Okay, so that's what. So this is a thing that you remember, guys. This is something that you remember. 1 year, 2 year, 3 years, 5 years, 7 years, 9 years, 11 years. In between 4 years also you can manage it. 4 years, 6 years. I did not mention 6, 8, all right. You can manage that also. Right, I have a 4 years, sir. 2, 2. 6 years, 3, 3, or 2.5, 3.5. That's how you will be able to manage. So this is the logic that you have to follow, guys. Right? I hope that is answered. Amir, right? Yeah. This is how you have to manage. Yes. Yes, Prasad, you have any question? Yes. Correct. We will be logging it. See, we don't have to monitor every day. So usually, sir, when you're working in the company, so if some pipeline is running every day, so if it is running smoothly, you don't have to monitor. But if something is failed, you wanted to get an alert, hey, this is failed to my mail, right? So you get an alert to your mail saying that this was failed, and then you go and check your logs, check your logs, right, properly, saying that why it is failed and all of those things. So logging and monitoring is for you to properly verify it later. But if you wanted to get an alert, you just do some kind of a mechanism, writing it to your mail or Teams or whatever it is, right? So that's how you do that. You mentioned that the same thing. You mentioned your logic also in the same thing, right? In your code, say, hey, if this pipeline is taking more than expected. Again, you try to stop it here. You raise an alert. Okay, you stop it and raise an alert. Yes, us. Yes, I'll show you, but not all the things. But I'll show you the mechanism how it works. Yeah. Yes. Sure. I see. Oh yes, Narendra. You have any question?
Yeah. GCP having a lot of modules with different functionalities,
Mhm.
but as a developer, and we don't have that much of scope over the project level. There will be only for a few modules like BigQuery, GCP, and Dataflow,
Mhm.
and Overflow. So only few of modules only we are going to touch it over the during the development. So these sessions looks like it's overall even all modules.
Not all
So
modules. Not all modules. A module or not or a section related to the data engineering only.
yeah. So is there any only dedicated training for only for a couple of modules like the combination
Mm,
of BigQuery, GCS, Airflow, Dataflow?
no,
Uh,
such course is
and
this one only. See, such course is
sorry,
this one. That is this course only. So you try
I
to
agree
understand. I'll
that,
tell you one thing. I'll tell you one thing. See, wherever the companies are using more, I stretch more. Okay, wherever it is not used. For example, cloud functions. It's only 1 hour session. PubSub, only 1 hour session. Data fusion, only 1 hour session. Airflow, 4 to 5 hours. Data flow, 7 hours. Data proc, 7 hours. BigQuery, 8 hours. Cloud SQL, again, 2 hours. GCS, 2 hours. So wherever it is more, I stretch more. And Terraform and Bigtable is complementary. It's already videos, right? Wherever. So that,
are you covering the cloud builder?
no,
No.
no. Whatever we are covering, it is mentioned here. If it is not
So
mentioned here, it is not covered
if
here.
we
Yes.
need more on the in-depth over the particular modules, what we can do?
I am going to cover in depth only these
No, no,
topics.
no.
Yeah.
I agree.
Okay,
So
not sure,
no problem.
not sure about that. I mean, because see, whatever I am covering, see, first thing I would like to tell you guys, GCP data engineering, I would say 2.5 years back, I only have started the GCP data engineering. At that point of time, I did not see any trainer in India who was started teaching the GCP data engineering. And I started GCP data engineering. Many people, actually my students who learned from me, they are actually teaching now. Okay, they are also teaching now who learnt actually from me. So at GCP data engineering, a best course, if you go and check it out, you will see my name, Saidhul sir. Okay, you will see my name everywhere. Okay, so best course for the GCP data engineering, which covers job ready program, is GCP data engineering, is by me. And you can check it out outside. If you think that someone is teaching more thing that is required for you, it's your choice if you wanted to go. But the thing is that if one wanted to get a job, if one wanted to work comfortably in the company, right, getting the job is easy because there is a plenty of opportunities are there. But if you wanted to work comfortably in the company, so your company may be using tomorrow PubSub or a cloud function, if I'm not teaching it today here, will be a big trouble for you in the company. So just wanted to make yourself, your career in the safer side. Whatever the GCP data engineering, I will for sure cover here. Some of the things which are outside it, some of, for example, Terraform is not required for data engineers, or why you are covering. See, some of the data engineers nowadays working on the Terraform, not to create any kind of resources, not to deploy anything, but they're interacting with the Terraform to do some kind of a schema changes, or maybe the data set changes, maybe such kind of a thing. If I not telling what is Terraform here, they are facing some issues. So such kind of things I try to put here. Earlier, I was not teaching Python. People told me, sir, everything you are covering, but Python is also very important. But we do have some Python knowledge, but how much amount of a knowledge for the Python is required, we do not know. Again, I've started mentioning that, right? So Apache Beam, teaching Apache Beam, you nowhere see someone is teaching Apache Beam with a very good knowledge. We are covering with an Apache Beam 7 hours with everything. Okay, so try to focus on, try to follow my lead. For sure you are going to get the job. For sure you are going to get comfortably work in the company. You don't need any support. People take support. For some people, they attend some course, they crack the interview. Cracking the interview is not that much hard with the course. But the thing is that when you're working in the company, that's where the real thing comes into the picture. People take support, they are not able to support you properly, the job is gone. But if you put effort now itself, whatever I'm covering here, for sure you will be able to do your own work on your own itself. Okay, so such that we will be covering the course. Yeah.
Yeah, few things. So,
Mhm.
are you going to cover the data flow through airflow and data flow combination, or it's only for airflow?
No, you can see here data
No,
yeah, I'm
during the exercise.
using the exercise. I'm telling you, I'm showing you here. So airflow with the data flow combination.
Okay, that's fine to me. I don't need a depth. The
Compose.
second one is to make a scalability during the data processing. So to increase
Number of,
the resources,
yes,
are we?
you have to mention that. It's a very simple thing. People may be asking in a very bigger question in the interviews, but the simple thing is that you just have to mention 2 to 8 or maybe 4 to 8, so that automatically it will be scalable, the number of workers, right? It's just a configuration. Yes, we will. I'll show you.
The
I'll
main
show you.
question. So,
Yes, yes, yes. I'll show you for sure.
yeah, so basically, I'm new to the GCP, and so learning on the scope of airflow and data flow
Hmm.
majorly
Sure.
to get the pipelines. So that's why I'm keeping focusing on those areas
Sure.
with the opportunity.
Sure, sure. It is going to be very interesting sessions. For sure, you are going to learn those topics. And I'll tell you most of the things. Even whatever you are expecting, I'll tell you even more than that. So it is going to be interesting again. I'm telling you, for sure, you are going to learn. Okay? Yeah.
Yeah, the last question. Sorry to
Yes, yes,
elaborate.
yes.
So during that practice in local and so there is a free GCP account
I'll tell you
available
how to create. I'll tell you how to.
inside, or
Huh.
can I
Huh.
join?
That's there. That's there. I'll tell you how to create a free tier account in. Yes, yes,
Thank you.
yes. Yes, Sai Charan, you have any question? I'll share you. I'll share you, Sachin. I forgot yesterday, but I'll share you today. Guys, for those people who have not attended yesterday's session, who have not followed the entire session yesterday, the recordings will be there with an admins. They will share you. Okay? Yeah. Yes. 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 N- Not fully, not fully. Maybe I'll be showing you a traditional system of a MySQL to the Cloud SQL. Such kind of a exposure I'll be showing you. MySQL to the Cloud SQL. I'll show you how the people will be working in the MySQL, how it will be moved to the migrated to the Cloud SQL, MySQL in the Google Cloud Platform. That one, but not Teradata. No. Yes. But the process is same. The thing is that if I'm telling you one migration process, it is the same. The only thing is that the that tool or that interface changes, but rest of the things are same. The approach is same. Yeah. Yes. Yes. No, no, no. It's a very good time. So GCP is well known to the people from last to 2 years only. Okay, last 1.5 year to 2 years. Having a 2 3 years of experience in the GCP is very rarely people will have it in India. In India, people having a 3 years of experience in the GCP is very rare, very very rare. You hardly see some fingertips. You can able to count them on a fingertips. 10 15 members will be there in entire India of 3+ years of experience in the GCP. Out of all them, one of the person is me, having 4 years of experience in the GCP because I work for abroad for some time. So that's the reason. Okay, for GCP you will be very rarely see. 2 years you may be seeing now because my students only 2 years only. Okay, 2 years you may be seeing that. 1.5, 1 plus 1.5 are more number of students are there. Okay, around some 500, 600, or around 1,000 people are there in the GCP. Yes. Now. Huh. Yes, yes, yes. Until there only I have told. Until there only. Comparing my experience only. Yes. Yes. Yes, maximum you can put. Yes, yes. In the future, after 2 years, you can put 5 years also. Yes, but now if you put only 3 years, maximum is enough. Yeah. Of course, there's a scope. Of course, there's a very good future for the GCP and Azure for data engineers, I would say. Okay, very good future. Even AWS is, I wouldn't suggest, but Azure plus GCP are the good roles for data engineers, because GCP is offering you plenty of data engineering tools very cost effective. Most of the companies started using the GCP. There's a good future for next 15 years for the data engineers in the GCP for sure. Okay. Yeah. Yes. Okay. Okay. Any other questions, guys? Anyone?
No.
Yes, Purna. No, actually, it's not a a role. It's a so some knowledge from the API. Okay, so there's a API separate course will be there, and the setting up these APIs and APG is one of the source for the infrastructure engineers. Okay, so you don't actually get it in one single course, because maybe you can check it on online. Okay, you can check it on the YouTube or something. What is APG and how to set up? Once you have a basic knowledge, more than enough, because cloud will take care of most of the things. Okay, so setting up the API is very straightforward in the Google Cloud Platform with an APG. I have worked on APG, so that's the reason I'm telling you. You can check it out online, because you don't find out a one single course who majorly focus on the APG and APIs. Okay, you have to find out different courses. They may talk about a lot of things, including it 5% of the topic is APG. Okay, so that's all. Better thing is that go for a YouTube and try to check it out what is APG and how to set up. 1 or 2 hours you'll be able to cover. Yeah, yeah, that's a good idea. Yes. Okay, okay, guys. I think this is it for today, and we will see a few more things in the next session. Tomorrow we are having the third demo, guys. Sorry, we are having the third demo session. Please do not forget. Please try to attend the third demo session. Right? So yeah. So on Hadoop knowledge is not required. Hadoop is already those people who are already working on the Hadoop are get laid off already. They are terminated in the companies. No Hadoop in the picture now. Okay, so big data is we are going to cover already. Okay, yes. Okay, guys, thank you all. Have a great day. Bye bye. We will meet in the tomorrow's demo session. Please do not forget, at the same time we are having the third demo tomorrow. Thank you, guys. The recordings will be shared to you guys. Thank you all. Thank you, guys. Bye bye.